STV is an engineering firm that's rapidly growing in this area, and I'm one of the recent additions. Before this, I was a cooperative and automated transportation program manager at TxDOT. And so I've had a good opportunity to sort of go around this industry, roadway digital infrastructure. And as we focus today on data, which is really the bedrock for this, I think we've put together a panel here of people who are leaders across all facets of this going forward. So I'm very excited that one, they all picked up my call still, even though I'm now a consultant, and we're willing to come onto this call with us. And I think there's going to be a lot of lessons to be learned today about some of the forward-looking things that are happening in this space. We've got somebody from GM who's going to speak a little bit about the origination of this data. Somebody from Miovision, which is an on-road sensor that's using some artificial intelligence to really figure out, how to harvest data purposefully. TxDOT is a representation on building a community of practice around some of this data that you can now pull from vehicles and other sources. Kentucky DOT is going to be speaking a little bit about this great data exchange model that they have actively in place that are informing their systems. And then, of course, Representative Florida DOT will also be speaking a little bit about data exchange and sort of leading into the future. So I'm going to let everybody introduce themselves, and I'm going to turn it over to Niti here at the beginning to really start with the basis of what are we here today, what has enabled us with connected vehicle data, and kind of where we're headed with that.
Thanks, James, for having me. My name is Niti Anand, and I'm the head of strategy and business development for GM Future Roads, which is a platform of data insights. So since the topic starts today around data, I'm going to go ahead and share my screen a little bit and talk about who we are and what we do. So as you all know, GM has a vision of a world with zero crashes, zero emissions, and zero congestion. And we've taken that vision to heart, and people across the company are really working hard so that we can move the needle and get closer to that vision. From building safe vehicles and putting in features that enhance safety, to our platforms like GM Future Roads that I'm going to talk about today, to save speeds as well as post crash care with OnStar. GM is committed to getting a future where we have safe infrastructure. And so, as we talk about certain vehicle features that have started making their way into all model years, or most of them, you will see that we work with leading institutions to test and learn them. When these features make it into the car, you're looking at, an 82% reduction in brakes and crashes. You're looking at, a 40% reduction in rear-ended striking crashes. So all of these new technologies that make their way into the vehicles are really helping us in seeing that Vision Zero come to life. So where do we get our data from? So a lot of folks want to know about that. So today's vehicles really do collect a lot of different kinds of data. We don't really harness all of that data. Some of it is just there. As you can see around the vehicle, I have kind of looked at a couple of different sensors that are there, which actually collect some of the data that is then used to inform some data insights that we leverage and use for our products. Some of these, as you can see on this chart here, talk about how we detect potholes or how a windshield wiper can help you understand, how many inches of rain or snow are coming down. We can assess temperature as well from the sensors of the car. Road quality or road roughness can be measured, through this stabilization system. So these are some of the things that your vehicle can actually tell you that inform the products that are built and sold outside. The number one thing, though, that is important to General Motors as we collect data is consumer privacy. So unlike other institutions, General Motors works on an opt-in basis, which means our consumers have to agree to share their data for multiple use cases even before we actually use it for any products. And this is a best practice as an organization because we take data quality as well as privacy very, very seriously. So this is connected data. And how do we use this data? We leverage some of this data to enhance products for our drivers. So think about you driving on a road. A consumer, we want to know, is there a crash ahead? Is there a risky road segment? And then when we work with the public sector, who is responsible for, maintaining the infrastructure, we have started leveraging some of these data sets to go ahead and create valuable insights for them so that they can make informed decisions. This data is leveraged, for example, probe data has been used for many years in helping identify congestion hotspots and, for traffic routing and monitoring. Today's data sets in tools like what GM has built with INRIX, Safety View, we use it to go ahead and talk about risk scoring. Where are safety risk spots? Where is a lot of heartbreaking happening? Where are there problems on the road that we want DOTs to go prioritize? It can be used for traffic planning, safety planning. Recently we used data to help 2 different cities identify where to prioritize their projects because they had limited funds. Both very diverse geographically. One of them was looking to put in a light rail station, connecting them to, an urban city. The other one was working to look at growth and expansion. In one case, they were looking at safety for micromobility for vulnerable road users to put in bicycle paths and maintain safety. And the other city was really looking to account for expansion and growth. And data kind of helped them really prioritize which areas they needed to focus on and what projects can they use. So the recent study that I just read said about 40% of agencies are using some of the other data today because it helps them make informed decisions. And in the future, I believe the data can help replace a lot of hardware that is costly, not only to install, but also to maintain. So that's a little bit about me and the data that GM is collecting from its vehicles and how we aggregate, anonymize it for the privacy of our consumers. And then we go ahead and share it through, applications like Safety View and help agencies bring about infrastructure improvement. James, that's all I had.
Perfect. And Niti, could you maybe just talk a little bit about how granular the data is? The data comes pretty frequently, right? So it's a really good insight.
Right. So data can be as granular as, look at our telemetry data. You can get it every, 3 seconds, 5 seconds. It all depends on use cases, I would say. In some cases, when I talk to certain agencies, I ask them, what problem are you trying to solve? Because if you're looking at an operational use case, you might need a lot of the frequency of data. If, let's say, another agency I spoke to, I think it was at TRB, they mentioned they wanted to monitor work zone safety. So if they put in some new, a risk assessment, or they did something to help improve the work zone safety, they wanted to measure it. And so they wanted it at about every 15-minute intervals, or they wanted it twice a day, for example, depending on what they implemented in that project. That's a different use case. That's an operational use case. When you look at planning, some folks are happy with 2 weeks, every 2 weeks of getting an aggregated data set, which then can tell them historically what the trend lines are. How are things improving? Where should they focus? One of the features we have in our tool with INRIX, Safety View, tells you a road segment ranking, for example. We are able to rank all the streets in your city, and we are able to tell you which is the riskiest road segment. Our true near miss data, which is a game changer, as you know, we've talked a little bit about it, that comes from ADAS vehicles. So that's a smaller subset than our 10 million car park, but it is a game changer because it's more preventative. We can tell you where forward collision notifications are going off in vehicles, where automatic brakes are going in, probably for you to look and see if a lot of that activity is happening in a particular intersection or on a highway. There's something going on there that we should probably send someone to take a look at, inspect, do a study, and see if we need to improve it. So to answer your question in a little long-winded way, it can be 3-second telemetry data that can be provided very quickly, or it can be, a quarterly aggregation of data, just depending upon the use case.
I appreciate that answer. I really appreciate GM, I think, for being one of the leaders in this field as an OEM to come to the table. I think that's a big deal. So I think there's a lot of gratitude here. But okay, let's go to Kurtis. Hey, Kurtis. Kurtis with Miovision. Kurtis, take it away.
There we go. Let me see if I can figure out how to share my screen here. There we go. Can you
We
guys
can see it.
see that? Okay, perfect. So similarly, I only have a couple of slides here, but I'm going to give you guys two metaphors to sort of stay anchored in, and just to give you some context. So Miovision provides devices that go into intersections, provide a range of different applications, from detection to adaptive control to safety analytics, the counts, sort of, one-stop shop in terms of a device at the side of the road. And then we provide a whole range of analytics that live up on the internet, take all the data coming from that device, and we provide insights like signal performance measures and safety analytics, and traffic counts, and all sorts of things that cities use to make decisions about how to run the city. So I'm going to give you two metaphors. Lots of talk about digital infrastructure these days. So what is digital infrastructure? So the first metaphor that I'm gonna talk about is to try to link this transformation that's happening in the ITS industry to something that most of us on this call. I don't want to presume anyone's age or vintage here, but most of us on this call have probably lived through some version of this timeline in our professional careers, right? So there was a time, 80s and 90s, when this was our desk. It was filled with stuff. You had an atlas, you had a Rolodex, maybe you had a clock radio, the fax machine, and over time, all of those things that were different pieces of hardware, right? Like different physical things that you had to buy and put on your desk. Over time, those transitioned from being different physical pieces of hardware to software applications running on computers and phones, right? So over time, you had this sort of consolidation, take lots of different pieces of hardware, put them all together into one common piece of hardware, where the differentiation was entirely provided by software. Intersections today very much run this way. You have lots of different devices that go into a traffic cabinet, provide different functions, emergency vehicle preemption, transit priority, detection, control, communications, different capital purchases for each one, different market specs that you have to procure against. Then you have support, ongoing maintenance involved in each of these devices. In a software-defined world, similar to what this timeline suggests, you have essentially common devices, one or a small handful of devices that can do all of those same functions, powered entirely by software. So when we talk about digital infrastructure, what does that mean? My view, at least, is that it's going to follow a very similar evolution. The market will follow a very similar evolution to the smartphone and the personal computer, and that more and more of the things that we want to do in our transportation networks will become software defined over time. This will reduce the number of devices that have to get deployed at the side of the road, reduce the capital purchase quantity, like the amount of capital purchasing you have to do, reduce your maintenance issues, as more and more of these things become software defined. The other benefit of this approach is that if you want to upgrade, the 330,000, give or take, intersections in the United States, today you'd have to do 330,000 manufacturing processes, 330,000 truck rolls, 330,000 installations to add a new function to an intersection in a hardware-based paradigm. In a software-based paradigm, you can click a button and you can upgrade 330,000 intersections all at once. So the rate, the velocity involved in, or the frequency, I should say, involved in making changes and making improvements, to improve safety, reduce congestion, goes way up in a digital infrastructure paradigm. The second metaphor that I'm going to give you here is, and you'll have to bear with me through this one, but we talk about platforms, right? So in a digital infrastructure world, you have these devices, call them the smartphone or the intersection, that are out there at each of the intersections. They're generating data, they're actuating control, they're connected to some sort of cloud-based service. But fundamentally, much like the high school reunion, was the driver of the high school reunion was to go and see your friend Bob, who you hadn't seen for 10 years. You'd go, pack your bags, you'd get on an airplane, you'd fly to your hometown, you'd go to the high school reunion, you'd find Bob, near the punch bowl, and you'd talk to Bob about what happened over the last 10 years. 10 years later, you're still curious what Bob's up to. You go back to the high school reunion, have another conversation with Bob. So this was a high friction, low frequency experience, right? Every 10 years we made a big effort to travel, stay at a hotel. And once every 10 years we could have this high friction experience where we went out and we got an update on Bob's life. We compare this to Facebook, right? Facebook provides the same underlining value driver, right? We're curious about Bob, but now we can, every morning when we wake up, we can roll out of bed, we can look at our phones and we can see how Bob's doing, right? What did Bob have for dinner last night? What's Bob, oh, Bob just switched a job. Oh, Bob got a dog. We get this much lower frequency, much higher frequency, much lower friction experience to do the same thing, which is fundamentally, this driver of being curious about Bob. So if we apply this to a digital infrastructure world, all of a sudden, the workflows that we experience in the market, right? Because citizen complains, we do a traffic study, we do a signal retiming, we drive out to the side of the road and we redeploy the change. This is a high friction, low frequency type of environment because it's based on this analog, largely analog market function. In a digital infrastructure paradigm, all of a sudden that same workflow, which is meant to respond to the citizen complaint and improve traffic, some aspect of traffic flow, becomes a much lower friction, much higher frequency type of engagement. So I think in our view, the smartphone of the intersection is coming, and this notion of digital platforms that enable a lot of the workflow that we do today outside of our tools. These are both things that become possible in a digital environment. And I'll just leave you with one last thought. One of the things that's happening, and GM spoke about this, is that much like intersections are becoming software defined, vehicles are becoming software defined, and as a result, vehicles want more and more services, like more and more data that is provided. More and more services that are provided by the data coming from intersections, and we're seeing some examples of where there are cities that have made that data available to car companies. They're buying that data, and I believe, and certain market reports would suggest that over time the demand for data from intersections is only going to grow, and that the opportunity for cities to use the demand for that data to pay for the transformation, right, to pay for the smartphone in the intersection, is only going to grow over time. And so I think that you have the smartphone in the intersection metaphor, you have the sort of platform, or the Facebook metaphor, but there's also this business model shift that's coming. It's going to enable an acceleration such that it doesn't take us 15 or 20 years to see connected vehicle infrastructure get deployed at scale, but maybe it takes us 3 to 5 years to see it deployed at scale. That's it for me.
Very good. As I'm listening to you, Kurtis, I mean, it really, I've been having this conversation today, actually, at this conference, is about, you need to think about the future, right? If you want to run one application now, you can do a single pipeline from application to end user, but you need to think about when you start to layer applications on top and what that architecture looks like. And I think that you laid out that's the future we're headed towards. And so from day one, as you're trying to go from point A to point B with data or whatever, you need to be thinking about, here comes point C and point D, and address that. What do you think?
No, I agree 100%. And this is the power of software-defined anything, right? Software-defined phone, software-defined intersection, software-defined car, is that you don't have to necessarily think about every possible use case that you might ever want to deploy on it. Because it's software-defined, you can change its function over time, right? And so what the important thing is, you think about the types of data you need, right? So what are the sensors that I need to have in the phone, in the car, in the intersection, and then the ability to update the software function, right? So and an intersection, we need to collect certain types of data about multimodal. We need to collect multimodal information, collect information about vulnerable road users. We need an ability to actuate, to change the lights from red, yellow, green, and then we need enough computing power that we don't eventually run into a limit in terms of, otherwise you have to go buy the next version of iPhone to run all the apps. But beyond that, world's your oyster in terms of the functions you want to add.
Very cool. Thank you so much. All right, let's go to Beth from TxDOT. Hey,
All
Beth.
right. Hi, James. Can you see me?
I can see you.
All right. I am sharing my screen here. Let me know when that comes through.
I will. There you go. Go ahead.
All right, awesome. Hi, everybody. My name is Beth Wyatt, and I work at the Texas DOT. And I am in the Strategic Initiatives and Innovation Division. And specifically, I'm going to share with you information about building a community of practice around roadway data and kind of the way that we've come at it and how we're moving things forward. So one thing I want to make you all aware of is we're working on something called our CAT program. This is our Cooperative and Automated Transportation Program. And this program is kind of changing the way we're thinking about how everything comes together as a DOT. You know, traditionally, we're thinking about our organization and our organizational silos. This CAP program is really talking about how information flows across the different work that needs to be done in order to have and support a cooperative ecosystem of both the physical and the digital infrastructure. So, and in thinking about this, at the same time as TxDOT was setting up this CAP program, there's this little thing called a statewide, or excuse me, at the same time, there's this little thing called the statewide data contract that we have set up, and I'm going to tell you a little bit more about that. But it was very clear that this data is very important. And so we started thinking about it as the digital roadway data. And it's really anything that describes the roadway, and it's needed in order to enhance connected vehicles, infrastructure, and it can be used in all the different ways that we've been hearing about already in this presentation here today. And so back to the statewide data contract, these two things have come together now. And James Kerr was a part of both of these things, but they've come together now. And the statewide data contract has, it was previously put out, and INRIX was an awardee. And so INRIX and their sub Replica are our current vendors on this contract. And it's been our want to provide this data and the data services that come through here, not only to TxDOT employees, but also to other entities at the state, like other agencies, universities, in some cases, MPOs. And so feel free to check out this box.com link. You can see our product sheets that are out there and see what's available. And if you work in Texas, or work with TxDOT, either one of those, you might be able to utilize this data as well. And we encourage you to go out and do just that. So as we were working on getting people to adopt this data, we realized that we needed to talk about it more. Just having the contract was not enough. And so we set up a user group that meets monthly. And this is just something where we invited, you know, everybody we could, basically, TxDOT people, external people working with TxDOT, universities, people that are interested in using this data and putting this data to work. And so monthly we come together and we talk about the different work that people are doing and how this data is being put to work. Some of these things are really innovative. Some of these things are not so innovative, but I think there's a spectrum happening here where because TxDOT is so big and we have so many districts, we've got to constantly be reaching around the state in order to ensure that everybody is aware, one, that this stuff exists, and two, that it's put to work. And then also reaching out from my perspective to understand what's being done, because there's a lot of cool things that are being done in all the different districts. And it's hard to be aware centralized of all those cool things being done. So it's really great to bring the community together and be able to talk about all these different things. And so if you would like to come and be a part of our user group and listen in on all the things that are going on, please feel free to send an email to text.catdata@texdot.gov, and I'll get you on the invite. And now that said, we're doing something a little bit different for March. So March, we are really opening the invite to pretty much anybody. If you're using roadway data in an innovative way, in a not innovative way, but you're doing great things that are impactful, we want to invite you to bring that content into our user group meeting. So if you're interested, please send to text.catdata@textdot.gov your name, designation, abstract, title of your topic, and one slide, so I know you're serious, about what it is that you would like to bring into our forum. We'd love to have you share your information and just be a part of our group that comes together to talk about how we put this information to work. And now, on a similar vein, but slightly different, TxDOT is doing it again. We're going to go out and we're going to look for another statewide data contract. And the procurement team has approved me to share with you all this slide, just talking about that new solicitation that we're working on. It's going to be a multi-award solicitation, high dollar, and it's going to be for traffic data and services or roadway data. And so if this is something that you're working on or working with, and you think you have a service that might facilitate TxDOT's goals of safety and mobility, please be watching for the solicitation to come out. And please don't send any questions to me. I've got Nora Okoa's email address on the screen for questions, but really looking forward to having more services made available, again, not just to TxDOT, but to other agencies and entities in the state as well. Because the more we all are using this data, the more we're cementing the change that ultimately we're trying to create. And that's it for me, James. Back to you. Thank you, everybody.
Very cool. Thank you very much. Beth, can you put that information, who they should email to get the invitation to the groups in the chat or something? So, you know, I used to work with Beth on this and I really just watched her build it into what it's become today. But I think it's a great opportunity for nationwide, maybe worldwide, to just learn about how some of these use cases are being implemented on some of this data that we heard about earlier coming from Niti and Kurtis going forward. And it was interesting to follow up on those things because, Beth, can you talk about the different entities that you would see when you did that little, the wrap up? You would get the email addresses. Where did folks come from?
Oh my gosh, folks were coming from everywhere. We've got the different universities around the state of Texas, but then also other universities that are, you know, the think tanks that all these universities make. Purdue was on there, Caltrans has been on there. So we get other states coming in too. We have folks from FHWA joining us. And then of course we have folks from planners to district engineers that join our call to listen in, and we just change up the content, and we're always very clear about what the agenda is and stick to that agenda so folks can jump in at a time that's best for them and see that content that they're looking for. And we also post content after the fact in case somebody misses something. But yeah, we've got people joining us from all over the place. It's really cool to see.
It is very cool. And of course, anybody on this call, if you do something similar to this, we'd be happy to hear about it as well. I bet Texas is not the only state doing this, and just having these open forums to continually share what we're learning as a community as we develop this data, I think is extremely powerful. Thank you, Beth. Really appreciate it.
Thank you. And I'll put that email address in the chat.
Very cool. Thank you very much. I think we're gonna head to Chris. Chris, you there?
Yes, thank you. Let me grab a screen
While you pull that
share.
up, Chris works for KYTC, the Kentucky Transportation Cabinet, and he's a great example of looking ahead. He looked ahead 10 years ago, and I think built a really innovative structure for bringing some of this data in and doing some of these applications. Chris, take it away.
Beth, can you disable screen sharing, please? It's giving me a message.
Oh,
Okay, thank you. Okay, so yeah, I've just got a few slides just to keep myself on track here. I don't want to go through all these. Okay, can you see them? Great, thank you. Yeah, so I'm Chris Lambert. I'm essentially a data analyst for the Kentucky Transportation Cabinet. I spent many years in division of maintenance. Our ITS is in maintenance, and our primary use case was around snow and ice operations and just understanding what was happening on our roadway. I'm now in the State Highway Engineer's Office, and I work on performance management on a statewide basis. So many years ago, KYTC decided that ITS really needed to concentrate on data. Our theory was that technologies like DSRC and 5G and connected vehicles and all these sensors and edge computing and everything would just continue to produce more and more data. And while we saw a lot of agencies starting to purchase hardware and sensors and things, we thought, well, you know, they may go out and purchase a lot of this hardware and then not be able to use the data. And we thought, well, while there's still this decision-making point between DSRC and 5G and all this stuff, let's just go ahead and concentrate on data and grow some expertise in-house. And that's what we did. So in November of 2014, we actually started developing an in-house real-time big data system. We started with things like technologies like Hadoop and Spark and other distributed computing systems that were very new to the cabinet. And then we're now on Google Cloud. So some of those data sources, you know, we've grown these over time, but we grab like here data, we're grabbing icons data. I won't read all these to you, but we're collecting a lot of different data sources. And essentially all these are anything that's real time or near time, anything we need to update on a regular basis, and also combine with other data sets, kind of goes to our ITS group. And we're really kind of creating more of a data science team, like a real-time data science team. One of our personnel is a full stack developer. He comes from app dev. He moved over to the ITS group about a decade ago. And then I've got a GIS person. He's got about 10 years experience in highway design, and then about 15 years experience in GIS. But 10 of those 15 years has been working on our project and developing Python scripts and doing a lot of spatial work. And then I'm essentially the data analyst. I do all the visualizations and dashboarding. I also introduce new data to the team. So if a data provider comes to us and they've got data, I'll be the first point of contact, and I'll bring that to the team. So here's the new data set. Here's what it looks like. Here's how we need to use it. And then we kind of work through that issue. And then that ends up back at me where I'm able to communicate back to the customer, you know, like work zone monitoring, incident detection, snow and ice dashboards, et cetera. We've got a variety of use cases now. Again, snow and ice decision support's our big one. We do incident detection, work zone monitoring. We've got a fleet-based rolling work zones now based on our, this is anyone with a KYTC vehicle. If you're on the interstates and you're traveling less than 30 miles per hour for, I think, like 10 seconds or more, we actually introduce or we generate a work zone. And it's a temporary work zone, and we pass that information off to Waze, and we also create a work zone data exchange, temporary work zone for that as well. So we're trying to do more things to protect our workers. But how do we do all this? Really, this is kind of the basis of our snapping. We're grabbing lat longs or any type of geometry field from the data source. And we preserve everything that comes in from the data source. So if we grab something from, let's say, Waze, for example, and they give us 30 some odd fields of data, that's fine. We're just going to add 47 fields of data to that row. And that makes it easier for us to analyze. We're starting to use our district terms, our counties, our county names, the roadway names. So what that allows us to do, if you see at the bottom there, I can pick any date and time, any district, county, route, mile point, and then I can start to see, oh, there's a crash here from Waze and there's speed data from here. And I can start to draw those correlations between those two, and I can graph those out and visualize those very easily in a dashboard. So this really helps the end user introduce them to new forms of data that they otherwise maybe wouldn't have expertise in, right? But they're using our attributes to understand that data, and it kind of helps to bridge that gap. Incident detection, we've been doing this since 2015. When a Waze report comes in with a crash report, thumbs up of 1 or greater, and we see speeds 70% or less of free flow, we flag that as a detected incident. We let people know about it. Our traffic management centers, they get these email alerts so they can then turn around and try to find that. Work zone monitoring, same basic idea. We've got a geometry on the road. We've got streaming data in. So we use the work zone attributes, the beginning any mile point and beginning any timestamps, to kind of create like this block of data, right? From here and from Waze and everything. We use it as a filter for all of our other data. And again, a lot of people have deployed a lot of really expensive option or solutions to work zone monitoring, queue detection, et cetera. We're actually trying this first. This is easy to implement on our side because we already have all the streaming data. So again, we're trying to do some of these things. If you're in our organization, you're dealing with data, operational data, for example, this is kind of our workflow. The users, we all communicate. You all use Microsoft Teams. So we all have all this real-time communication happening on a regular basis about any type of incident. whether it's snow and ice, work zones, whatever that may be. So the users are all collaborating and talking, and then we provide them links and things out to these other tools, these other dashboards. And then we've got data streaming in to our real-time data system. Again, all that's processed against our linear referencing system, all that's stored and organized in a way that they can understand it. We produce a lot of derivatives, like again, the dashboards. We got email alerts, we got automated tweets. We've got a lot of things here that are automated for the user to interact with. We've also introduced APIs. We have one API built in-house, and that's for our snapping. We've got a couple of software providers now that say, hey, we generate lat longs in our system, but we don't really know anything about your LRS. Is there any way we can kind of like interact here with your all's system? We said, sure. So we have an API. It's typically used for snapping. So if you're a vendor, if you're a software vendor, you're generating a lat long in your system, you can send that to our API and we will return all those attributes to you: district, county, route, mile point, direction. We give you all of that information, and then you can actually store it in your system. If you've got reports and things you want to do for the users, that's fine. And we're actually working with a software vendor right now that we're doing that with. They're going to start using this API, bring that back in, storing it. That way our traffic management center people can see that. But of course, we're also pulling in that data feed and going through our normal process. So this is very typical in our organization. The other API usage, the other data sharing that we do, we also add people to our Google Cloud. So we've got universities, we've got contractors, and we've got other even other software vendors that they'll say, well, we're able to learn the Google APIs. So we actually just introduce them to our system. We have them in what we call a research project. The research project has a cap on it in terms of number of dollars spent per month. So if someone goes crazy, it caps them off, right? It's going to stop that and kind of alert us to that issue, and then we can address that on a case-by-case basis. But we've got several universities, like I said, we've got partners and things that are in there, and that allows them, instead of us creating an API that they have to learn, they just learn the Google APIs, right? We're on Google Cloud. Very well documented, very well supported. So that allows outside entities to say, okay, now all I need to learn is Google Cloud, like BigQuery API, to interact with our data. And again, very well documented and supported. So we don't have to worry about creating more and more APIs for people to interact with our data. Travel information, we produce that in-house as well on Google Cloud. That's another data sharing. Decision support, we offer 3 to 6 hours of data so that our operations people can see short-term trends, right? And there's a lot of pages there that you can see that the users can choose from. Work zone monitoring, we do a lot of summaries for work zones. We do also do details. So, the hours of the day and the days of the week and what the performance of that work zone is. And this, from the time the record is created to the time the record is closed out, even if you've got something that goes through multiple years, we're capturing data every 2 minutes inside that work zone from all of our different data sources. We've got alerts that we produce using Gov Delivery. So we've got email alerts. So yeah, we've got a pretty advanced, or we feel like anyway, we've got a pretty advanced system, but it's taken us 10 years to get here. And yeah, and I've just got some other stuff there about possible roadblocks and things, but I'll just kind of leave it at that for now. And I want to make sure I stop in time for questions and things, but
Chris, I know you could keep going on, and I would like for you to keep going on if we had more time. I think your system just strikes me as just so advanced and really worth 10 years of effort. And I was wondering, if you go up to that one with the Google Cloud, a lot of stuff that we hear from entities is security, cybersecurity, right?
Which one? This one?
Right there, that one right there, right? Can
Yeah.
you talk a little bit about how this facilitates being secure in your internal KYTC systems versus everything coming in from the outside?
Yeah, so one of the things that Google Cloud allows you to do, of course, there's a lot of encryption around all of this data, and they also allow you to even generate your own keys. So now some of our stuff, to be honest with you, some of this stuff is the dashboards we create, we actually make publicly available, but that data is cleansed by people that actually have expertise in that data and understand that what can and can't be shown there. So there's encryption for internal users. That's all role-based and account-based security. But then again, all of our public stuff is very available. But yeah, there's we don't do this right now, but we have the option to generate, again, our own encryption keys. that only KYTC can manage. So that does give us an added level of security. For right now, we're actually not putting anything that's like official crash reports from Kentucky State Police or something with sensitive data in it. We actually avoid putting that information in here because we do default to more openness than what we do closed. And some of the data, anytime we do load data sensitive data in there, it's actually put in a different project, and there's a completely different set of protocols around accessing that information. And so that's a much longer conversation.
Very good, but one that I know many the security officers, CSOs, would be interested to have.
Sure.
So I appreciate it, Chris. Now we're going to head to Florida, the sunny state of Florida, with Raj. Raj, you need no introduction, but I'll ask you to introduce yourself anyway. I'm sure, and talk a little bit about Florida's data exchange and look a little bit down the road as to what's coming with this data.
Yeah, thank you, James. Good afternoon, everyone. I'm going to go ahead and start sharing my screen. My name is Raj Ponnaluri. I'm the manager of the Emerging Technologies Program at Florida DOT. Just looking at the discussion topics, I thought it is good to share some more detail than we originally planned. So I'll very quickly dive into what we are doing here in the state of Florida from a data point of view, but also try to bring some of the topics together from everything we heard the last 45 minutes or so. So when people ask, why do we invest in data? The simple answer to me and for us is to say that the overarching objective is to make sure that the data will help to improve safety, to advance mobility, and really, at the end of the day, these data are supposed to benefit all the communities at large, isn't it? In other words, any investments we make should pretty much cater to the type of topics we deal with day in and day out in transportation, be it emerging technologies, whether it's safety, innovation, electric vehicle programs, rail transit, multimodalism. So there's data coming from many, many different directions towards us, especially at state DOTs and local agencies. And we are confronted with trying to figure out which ones are the most meaningful and how effective they're going to be. So do we have data with respect to all the modes that are out there? Absolutely. Thanks to the numerous innovations with the industry today, there are companies after company who are developing tools and techniques, bringing data from different sources, fusing them together and giving us the ability to look at information, whether it is with respect to pedestrians, bicyclists, advanced air mobility, unmanned aerial systems. I won't read all those that are there, but essentially all the modes, rail, transit, everything is covered today with respect to data. So there's no reason for us to say that we cannot get into a roadway digital infrastructure mode. So if we take a step back, we have all the necessary ingredients to do that. One of the things we do here in the state of Florida is to invest significantly in the research efforts, which is actually what led to us developing the V2X or vehicle to everything data exchange platform. So what you're seeing, actually, there's a couple of small videos at the top left. These are real videos from fisheye cameras. It was a research done at University of Florida. We were trying to figure out the movement of vehicles and bicycles and pedestrians and the trajectories, and trying to figure out where the near miss incidents were happening, at what particular time during the day, in which particular direction, on which of the 4 approaches, etc. The reason why this is important is because this is where data really starts showing and giving value in terms of decisions. So if we want to really accomplish the goal of roadway digital infrastructure at some future date, we absolutely need to start looking at our intersections first, arterials next, freeways later on, and so on and so forth. So there's data everywhere. When we started the V2X or Vehicle to Everything Data Exchange platform, the whole idea or the concept was to see that we bring information from the roadside units, from the onboard units, etc. Also merge the data with our SunGuide ATMS or Advanced Traffic Management System platform, bring the data from our data integration and video aggregation system from the FL511. I can go on, but there's numerous data sources which many of us have at state DOTs and local agencies. The question is, how do we bring them? How do we fuse them together? So we thought that this V2X data exchange platform would be the most appropriate way to proceed. We have developed numerous use cases. We completed the first proof of concept, or the proof of concept a year ago. It is already developing the use cases, and we are collaborating with entities who want to work with us. In fact, Ford is already on the team with Florida DOT, along with Southwest Research Institute, to develop this platform. The reason I spent just about a minute or so on the topic is because when we talk about data exchange platforms, and we just heard from our good colleagues from Kentucky, Texas, and others as well, you're talking not only about vehicles as probes, but also road sensor data. We heard a lot about the APIs, application program interface. We're talking about in-vehicle data that are being supplied by numerous companies today. We're talking about roadside unit type of data being provided by state transportation units and whatnot. So once you bring all these elements together, we can start making some sense out of the information that is available and start producing or pushing the necessary information out through APIs, whether it is for work zones, for secondary crashes, for queue warning, speed harmonization, integrated quarter management. There are any number of use cases we can get into, which is one reason I think the auto OEMs are also interested in working with different states in trying to figure out how they can leverage what we have in terms of data. The two extra things we've done here in the state of Florida, among the many other things with the Connected Vehicle Program, is the creation of the SCMS, the Security Credential Management System platform, to ensure that any data that are being broadcast are secure, coming from a legitimate source and whatnot. And also the roadside unit health monitoring system as a way to make sure that the units that are out there are actually functioning 24/7. And if they go out of operation, we need to know the health status, or we need to know the condition in which they are. So all these are, shall we say, the basic underpinnings or the background information that you need for a good and successful data exchange platform. With that, I will just say one more thing, and then I'll stop after that. So when people ask the question, what are some emerging trends? What are some emerging topics? Well, right there in the middle, in the center, I show them, whether it's artificial intelligence and machine learning. There is no machine learning without data, good data sets, and large volumes of data sets, just not any data set. And that means if you really want to get into leveraging or maximizing the use with artificial intelligence, then eventually we need to have machine learning. And that also means having lots of data, good quality data. Automated driving systems. This is another area that is emerging as a key topic, whether it's payment contrast or digitizing your infrastructure. But ADS and ADAS systems are beginning to look at data as the key ingredient to moving forward, especially from machine vision standpoint. Digital twins goes without saying that eventually if you want to collect the data, analyze them, and create, whether it is a 3D models or replicating what is happening in the field, both historic and real time, digital twins require a lot of data. And last but not the least, the roadway digital infrastructure would not be possible without bringing all these elements together, just as we heard from our other colleagues. With that, James, I turn it back to you, and happy to take any questions and fill in any gaps that you see, James.
There actually is a question in the chat. This may be for you and for Chris. Are you using the Open Mobility Foundation's mobility data specification to enable right-of-way regulation and two-way communication between mobilities companies and local governments? If not, how do you deal with standardization issues, especially with mapping?
Absolutely. James, you want me to go first?
Please, go ahead.
Yeah, thank you. Sure, absolutely. Yeah, I'll be quick. Great question. This is the question of the day of the year and whatnot. Data standardization. When we talk about stewardship that we can expect, say, from Federal Highway, for example, folks like John Corbin, they're already thinking about items of this type. And at this point in time, this is a work in progress, I believe. Work zone data exchange is just one example of how you can create data sets in a certain format to eventually bring folks together. That's my long-winded way of saying that we do not have data standards that I know of today. They are evolving, but there are some good examples around the country to look at and figure out where we should go next. James, back to you.
Sounds good. Thanks for answering that, Raj. So that's our panelists. We have a few questions here in the chat. Some of them look pretty targeted. And so we will get through to those. let's
James,
just,
I can answer the first one if you like.
yes, please, let's just start. So let's read the question and then go ahead and answer it.
Yeah, so the question is, how does GM ensure the privacy of consumer PII information about the data collected from consumers? I think that's a great question. So GM takes data privacy extremely seriously, and we are committed to safeguarding all the personal information. So consumers control really how we collect their data, because what we offer, when we offer them connected products and services, we do it, as I mentioned earlier, in an opt-in basis. So if you don't opt in, we don't collect your data, right? And for every GM vehicle, the vehicle owner must accept our terms and conditions and a privacy statement to even allow us to use it in our products and services. These documents are on our website. Feel free to take a look at them. And GM Future Roads really handles data in accordance with our privacy statements. So even though we're a startup within the company and we are looking at working with DOTs and infrastructure work, our consumers have to consent for us to leverage their data, or we do not. And plus, all the data in our tools are aggregated and anonymized. So no PI data is shared, and that's how we protect the privacy of our consumers.
Yeah, and I got in a rental car this morning and Apple CarPlay asked me to accept. And of course, I just hit accept real quick. And I thought about it afterwards and thought, well, there goes all my data. But I've also seen studies that I think Lisa Miller shared some there where they're changing attitudes around PII, that people are understanding that they're being tracked by a lot of things and that there might be some, a little bit less concern in the future going forward. But certainly, I think, as Niti explained, there are these safeguards in place. Let's go to the next one, Chris. I think this one is going to be for you. Great presentation by Kentucky. Does the Google Cloud platform also include publishing data to Google Maps? If so, can drivers traveling in KY see relevant information on their Google Maps application?
No, well, the generic answer is no. I mean, they don't. We use Google Maps for our essentially our 511 system, which we call Go KY. So we do push out data in that standard for publication, but we don't actually push data to Google Maps itself. We do share. Google Maps shares, they ingest Waze data the same way we do. So we do share data to Waze. We've seen some of our data show up on Google Maps through that interface where we've shared it to Waze, and then Waze has turned around and shared it into Google Maps. Of course, Waze is owned by Google. And then Google has also mentioned that they will utilize work zone data exchange. And we have seen that show up as well. And right now our work zone data exchange feed is down for a technical issue. But our software, our TMC software provider actually has an issue not allowing us to pass that data through right now. But once we get that resolved, our publication will be back up. But so no, they don't actually allow you to directly contribute to their Google Map platform, but they will certainly license it to you and let you pay them to put your data out there.
Yeah, so Chris, we know what you're doing this afternoon. But before I left Texas, there was this great, I wouldn't call it a softening, but there was a lot more communication being ramped up between most of the major mapping providers. It seems like there's been a change recently where they are starting to think more about being accessible with this data. And some of that conversation is happening at the federal level, and some of it's happening individually. In Texas, they have some, Beth, I don't know if you have any information about that in Texas with what INU is doing.
Yeah, so Enyu Lee, my counterpart, she's taking the lead on working with the major mapping companies like Google. And at this point in time, she's got the top 5 consuming our data from our Drive Texas feed. So that's something that TxDOT has been working on for many, many years in order to communicate to the public. But we acknowledged that, it's not appropriate to think that the public is going to go to the special website, the Drive Texas website, in order to get this information. And so our Drive Texas feed is now feeding Waze. So you see our information popping up in Waze. It's not being portrayed similar to what Kurtis was saying. It's not being portrayed yet on the other mapping entities, but they are consuming it. So we're working through the process of getting our data out there to where the public actually is able to consume it most readily.
If I can jump in, Beth, that's actually, I'm really glad you said that, because one of the themes that we started with when ITS kind of became more of a data hub was that we were going to meet users where they are. And that became kind of the mantra for Jason Sawala, which is now one of our executive directors here. That was something he just repeated over and over. So we actually have several data feeds. We've got data feeds going out for TomTom and others, but Waze works on data exchange. And we actually kind of made the effort to make sure that if someone came to us and said they had to have it in a certain format, we went ahead and developed that format according to their format and tried to, again, meet them where they are because they represent, the people on our roadways. So I'm glad you said that, because that kind of triggered an idea or a thought.
So we've got 4 minutes left, y'all. There's one great question here that I'm going to answer. I'll ask the panelists to please type any answers to these things that you see in the chat window, just the same as I can. Everybody's contact information and LinkedIn is available. I'm sure everybody would be willing to have conversations following this with this community group. But I really do want to tackle this one because this is something that I've seen around the country. Ohio, Nick in Ohio is doing a great job with it. Colorado, Kentucky, Florida, Oregon, there are many data exchanges that are being built. It almost seems like the industry is starting to come to this idea that Kentucky had 10 years ago about we need a data exchange to sort of be in the middle of a lot of this. And the question is how do you envision the various disparate data exchange platforms being morphed or merged into a national data exchange standard? And I think the word is standard. So who wants to take that one? Raj?
Sure. Thanks, James. Great question. There are many data exchange platforms being developed, as James has just indicated. We do have a very strong partnership across states. There's what is called the Connected Vehicle Pool Fund Study, the AV Pool Fund Study. So there's numerous fora or forums where we all interact with each other. We share information. John Corbin himself is leading the National Roadway Digital Infrastructure discussion. So that's one way of saying that we are working with each other, but I do have to say that we can do more, especially get into the details on what specifically is being accomplished in each particular case. At this stage, as I see, these are mostly use case driven, but we've seen how Chris has been doing work with his local agencies, bringing them on board. So there's definitely more work that needs to be done. But long story short, there is coordination going on at this point, which can be furthered for sure.
Kurtis? You came up.
Oh, I just figured toward the end here I would
show everybody
myself rather than hiding. Yeah.
Very good. Well, Kurtis, you can answer this last one, last 2 minutes. What kind of ADS and AI technology are you most looking forward to seeing or using in the future?
I'm sorry, ADS?
Yeah, AI or ADS. Probably ADAS, ADAS, I imagine.
I'll answer the question in a very broad sense. I'm generally a pretty, I've been in technology for 25 years. I've seen lots of hype cycles come and go over the years. And so I would say I generally wait for the hype cycle to end and then in the Gartner sense, the productive plateau to appear. That said, in this particular hype cycle, I'm blown away by the rate that AI is coming online. Initially it was through tools like ChatGPT, which were neat, but were kind of gimmicky and you had go outside of your usual workflows to integrate them in. But I'm seeing now like AI tooling being added to things like Salesforce and Jira and tools that are widely used in my industry at least in ways that I think are going to lead to 30 or 40% productivity improvements across enterprise. So I think certainly AI is maybe coming faster than we think, and I know we say that in every hype cycle, but I truly believe this one's is a bit unique. And I think for outcome-based industries that are focused on outcomes, safety outcomes, congestion outcomes, I think building tools that integrate the data, the types of data that we've talked about, being able to generate and disseminate today, integrating those into large language models that can help us to create better, more safe outcomes at higher frequencies in cities. I think that's right on our doorstep, and I'm pretty excited to see it come to fruition and at scale in the market.
I agree. That's all I have to say about that. Thank you, everybody. We're going to hand it over to Victoria before we go, but I do want to give a personal thank you to all the panelists who showed up today. I learned something that every time I listen to any of y'all, I learned something, and I do appreciate it. Victoria, back to you.
Thank you everyone for coming to this webinar, and hope you all found it very interesting. We have our third webinar in the Digital Infrastructure webinar series sponsored by STV. That will be on signalized intersections with a focus on traffic signal integration. And this one will be held on March 28th at the same time, 2 p.m. Eastern time. So if you want more information regarding that and you enjoyed this presentation, go to the ITS America website where you can register for that. Thank you, everyone.
Thanks.